Okay, let's continue with our assignment on chapter 11. And let's pick up where we left off, alkenes and alkynes. Let's work on question number 1123. Question, identify the following alkanes, alkenes, or cycloalkenes, or alkynes. So let's begin with A. This has a double bond. So it therefore is designated as an alkene. Alkenes have double bonds. Let's move to B. B has a triple bond. So this is an alkyne. Alkynes have triple bonds. C, this is a double bond. So it is also an alkene. D. This has a double bond. It's therefore an alkene, but it's cyclized. So it is a cycloalkene. So let's continue on with question number 11.25. Give the IUPAC name for each of the following. So let's begin with A. When you're given a structure, it's best to name that compound by starting at the end. For example, we know that this has a double bond, so it's going to be referred, it's an alkene, and it's going to end in -ene. Next, you count the number of carbons. 1, 2. 2 carbons is Eth. E-T-H. So this is ethene. Now, normally you would indicate where the double bond resides in the molecule, but since there's only one possible choice, it's not necessary to, in this molecule, indicate where the double bond resides. So the name of this compound is ethene. Let's try B. Double bond. So it also is going to end in an -ene. Longest chain, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the longest chain is 3. So that's going to be prop. Now, do we need to indicate where this double bond is? The answer is no, because really there is only choice. If I put the double bond here, here, or here, it will be the same molecule, so it's not necessary to indicate where the double bond is. Now, there is a substituent group, and that is a methyl group on carbon number 2. So that's going to be methyl propene. Do we need to indicate where that methyl group is? Adding a methyl group to propene, there's only one option, so it's not necessary to designate that that methyl group is bonded to carbon number 2. It's not necessary. Let's move on to 3. This has a triple bond, so it's going to be an ine. The longest carbon, 1, 2, 3, 4, 5. 5 is pent. So this is pentyne. Now this triple bond could really be anywhere in this molecule, so we do need to designate where the triple bond is. It starts at carbon number 2, or maybe it starts at carbon number 3, moving in this direction. But we want to pick the lowest number, so the direction of counting is 1, 2, 3, 4, 5. This is carbon number 2, so this becomes 2. There are no other substituent groups, so this compound's name is 2-pentyne. Let's try D. Double bond, it's an alkene. It's therefore going to end in ene. The longest chain is 4. So that's bute. So this so far is a butene. But that chain of 4 is in a ring, so it's a cyclobutene. There is a methyl substituent, so this is going to be a methyl cyclobutene. The methyl group is attached to carbon number 1, 2, 3, carbon 3. Now we could have said carbon 4, 1, 2, 3, 4, but we picked the number that's lowest. So the name of this compound is 3-methyl cyclobutene. So it's an ene, it's a bute, it's a cyclobutene. It has a methyl substituent bonded to carbon number 3, so it's 3-methyl cyclobutene. Okay, let's move on to question 27. Draw the condensed structural formula or skeletal formula, if cyclic, for each of the following. So when we draw structures from their names, it's best to begin by listing the carbons first, or drawing the carbons first. So let's begin with A. This is a pentene, 1 pentene, so it's a pent, 5 carbons. So let's draw in those 5 carbons. 1, 2, 3, 4, 5. It's an ene, so it gets a double bond, which begins at carbon number 1. Let's designate this as carbon number 1. So there are no other substituents, so we just fill in the remaining hydrogens. CH3 for the terminal end, CH2 for the internal carbons, CH2. Now, this carbon, 4 bonds to hydrogen, 1, 2, 3 bonds, so it gets another bond, which is hydrogen. This, 4 bonds to carbon, 1, 2, so it gets 2 hydrogens. 1, 2, 3, 4. So this is 1 pentene. Let's move on to B. So what is the parent name? It's a bute. So bute is 4 carbons. 1, 2, 3, 4. 4 carbons. It's an ene. It gets a double bond in the number 1 position. So that's going to be right here. It has a substituent, methyl, at carbon number 2. Since this is carbon number 1, defined by the double bond, this is carbon number 2, so it gets a methyl group, CH3. There are no other substituents or double bonds, so we fill in with all the hydrogens. CH3, CH2. This one already has 4 bonds to carbon, 1, 2, 3, 4, so it doesn't get another hydrogen. This is going to be CH2, 4 bonds to carbon, 1, 2, 3, 4. So this is 2-methyl, 1-butene. Let's try number C. Okay, this is a cyclohexene. So it's a cyclic compound, so we can draw the skeletal structure here. Hex is 6 carbons in a ring, so we start with that. It's an ene, so it gets a double bond. So for cyclic compounds, it doesn't matter where you draw the double bond. It could be anywhere as long as it's just 1. There's a methyl substituent at carbon 3. Let's say this is carbon 1. 1, 2, 3. It gets a methyl group. Okay, now we could have done it this way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. So that doesn't count, so it's going to be 3. 1, 2, 3. So this is 3-methylcyclohexene. Let's do D. D is a hexine, the parent compound. It's hexine. It's not cyclic, so it's 6 carbons with a triple bond in it. So let's draw the 6 carbons. 1, 2, 3, 4, 5, 6. Now it gets a triple bond starting with carbon number 3. 1, 2, 3, triple bond. And there's a chloro group at carbon number 1. So this is carbon number 1. So we'll put the chloro group there. No other substituents, no other triple bonds or double bonds, so we fill in with hydrogens. CH3 bond, CH2 bond. Now there are 1, 2, 3, 4 bonds to this carbon, so we don't need another hydrogen. There are 1, 2, 3, 4 bonds to this carbon. It doesn't get another hydrogen. This is CH2, and this is CH2. 4 bonds to this carbon. 1, 1, 2, 3, 4. So this is 1 chloro, 3 hexine. So let's move on to question 1129 that has to do with cis-trans isomers. Give the IUPAC name for each of the following using the cis or trans prefix. So this is no different than any other way of naming these compounds. The first thing that you must do is name it kind of from the back of the molecule. So first of all, we notice there's a double bond, so this is an ene. And the longest chain is 1, 2, 3, 4. So this is a bute. So this is a butene. Now we need to indicate where the double bond is. So the double bond could be here or here. So it happens to be at carbon number 2. 1, 2. It starts at carbon number 2. So this is a 2-butene. Now the bulky groups are on the same side together above the double bond. So that indicates that on the same side is cis. So this compound is cis-2-butene. Okay, let's move on to B. Same idea. Double bond. So we start from the back. It's an ene. Okay, longest carbon chain is 1, 2, 3, 4, 5, 6, 7, 8. So this is an octene. We need to indicate where the double bond is so we can count from this end or this end. 1, 2, but we get to the double bond quicker by making this carbon number 1, 2, 3. So the double bond starts at carbon 1, 2, 3, 3. So this is a 3-octene. Now since it's a geometric isomer, we need to say whether it's cis or trans. Now since the bulky groups are on opposite sides of the double bond, this becomes a trans molecule. Trans dash 3. Trans dash 3 dash octene. So this is trans 3, 1, 2, 3, octene. Okay, so let's work on this one, C. It's got a double bond, so it's going to be named as an ene. Carbons, 1, 2, 3, 4, 5, 6, 7. There are 7 carbons, so it's a heptene. Where does the carbon begin? 1, 2, 3 versus 1, 2, 3, 4. The lower number is 3, 1, 2, 3. So it's going to be a 3. And the bulky groups are on the same side of the double bond. So that's going to be cis. So this is cis 3-heptene. Okay, let's move on to question number 31. Draw the condensed structural formula for the following. So again, when you're given a name and you're asked to draw the structure, it's best to put in the bare carbons first. So long name, but the bottom line is that the parent structure is an ethene. So that's 2 carbons with a double bond. Okay, now this is a trans compound with respect to bromo and chloro. So they're on the opposite side. Bromo, being a B, gets the 1. Chloro, being a C, gets the 2. So let's put the bromo on and the chloro on. They're opposite one another, so let's fill in the rest with hydrogen. So this is trans 1 bromo 2 chloroethene. Let's go on with B. Okay, so this is a hexene. It's a cis-2 hexene. So again, hexene, hex, that's 6 carbons. One, 2, 3, 4, 5, 6. The double bond ene starts at carbon 2. So let's put that there. So it's a cis compound. So the bulky group, cis methyl group, and this propyl group are going to be on the same side. So let's put the hydrogens on the same side. Okay, and fill in the rest. So this is CH3, bond CH2, bond CH2, bond, and CH3. So this carbon has 4 bonds, 1, 2, 3, 4. This carbon has 4 bonds, 1, 2, 3, 4. The bulky groups are on the same side. Okay, let's try C. This is going to be trans 3-heptene. So this is a heptene. Hept is 7. 1, 2, 3, 4, 5, 6, 7. Okay, and it's an ene starting at the 3rd carbon. 1, 2, 3. Double bond. It's trans, so that the bulky groups are going to be on opposite sides. So let's put the hydrogens on opposite sides. That means these bulky groups will then be on opposite sides. So fill in the rest. CH3 bond, CH2 bond, CH2 bond. Bond those, CH2 bond and CH3. So the hydrogens are on the opposite side. The bulky groups are on the opposite side. So this is a trans 3-heptene molecule. Now I could have just as easily have drawn these in this configuration. CH2, CH2, CH3. These are equivalent structures, or I could have drawn this one. Put this group down here, CH2, CH3. This is going to be a CH2, CH2, CH3. The hydrogen's up here. So these are also equivalent structures. Let's move on to question 1133. So here we have reactions with alkenes. And what happens is that in this case, the hydrogen adds across the double bonds and puts a carbon there and a carbon there, a carbon here and a carbon there. And in this case, water adds across the double bond and puts a hydrogen on this carbon and OH on that carbon. And in this case, water adds across the double bond. The OH goes on the carbon that is most heavily substituted. So the OH goes on that carbon and the hydrogen goes on this carbon. So it's a simple matter of just rewriting the structures with extra hydrogens or extra water across the double bond. So this is going to be CH. This is going to be CH3, CH2, CH2, 1, 2, 3, 4, CH2. So I'm going to add a hydrogen to this carbon and break up the double bond. And this is going to be CH3. Add a hydrogen to that carbon, break up the double bond. So this is CH2 and this is CH3. So in this case, we're going to add water across the double bond. So this is going to be CH3, CH2, CH, this gets an OH, and CH3. So one of the hydrogens goes to this carbon and the OH goes to this carbon, and we break up the double bond. So let's talk about this one right here. We can draw this as a skeletal structure. Okay. This carbon gets the OH because it's more heavily substituted. And this carbon gets the H, so there's going to be two H's here. So an H adds to this carbon, and OH adds to this carbon. And where it's not indicated, 4 bonds to carbon, what's not indicated is assumed to be an H. So this is the same as an H there, an H there, an H there, an H there. So this is the sort of the expanded skeletal structure. So this is really equivalent to drawing it this way. OH. Those are equivalent. But the point is that water adds across the double bond. The double bond becomes a single bond, and the OH is bonded to the carbon that's more heavily substituted. Okay. So let's move on to question 1135. These are aromatic compounds. Aromatic is a benzene ring, as you remember. And we're going to give the IUPAC name for each of the following. So if you remember, there are special names for aromatic compounds. In this case, this special name is whenever you have a methyl group bonded to an aromatic compound or a benzene ring, it gets the name toluene. So again, start from the back of the molecule, the back of the name. So this is toluene. And toluene is methylbenzene, so toluene. And it's got chloride, chloro attached to it. This is carbon 1 because it's toluene, and this carbon is named number 1. This is carbon number 2, which is chloro. So this is 2-chlorotoluene, 2-chlorotoluene. Now in the next one, there is no special aromatic or benzene ring. The parent name is benzene. So again, we name it benzene. It has a substituent group, so this substituent group's name is ethyl. Ethyl. So this is ethyl benzene, ethyl benzene. We don't have to designate which carbon it's bonded to because it's always going to be carbon 1. Okay, this is also not a special situation with respect to benzene, so it's called benzene. Now, there are 3 chloro groups, so that's a trichloro, and they're bonded at carbon 1, 2, 3, 4, 5. So this is 1, 3, 5 dash trichloro benzene. 1, 3, 5 trichlorobenzene. Okay, our final question is 1137. Draw the skeletal formula for each of the following compounds. So these are aromatic compounds. As you remember, toluene has that special compound in which there's a benzene ring with a methyl attached to it. This is equivalent to drawing it this way. 3 double bonds that alternate and a methyl group. These are equivalent drawings. Let's talk about 1,3-dichlorobenzene. This is not a special benzene, so it's referred to as benzene, so you draw the benzene. There are 2 chloro groups. Let's put one there, carbon 1, 1, 2, 3. Put one there, carbon 3, 1, 2, 3. So this is 1,3-dichlorobenzene. And this is equivalent to 3 alternating double bonds, chloro there and a chloro there. And last but not least, 4-ethyltoluene. So toluene is a special structure. It's a benzene ring with a methyl group. So that's toluene, just like it was up there. And there's an ethyl group on position 4. 1, 2, 3, 4. So as a skeletal structure, that's CH2, CH3, and that is equivalent to drawing it this way. 3 double bonds, alternating double bonds. Here's methyl, CH3, and here is ethyl, CH2, CH3. These are equivalent structures.